start with a right-angled triangle with side lengths of A, B, and C. Let's take 4 copies of this triangle and arrange them like this. This forms a square of side length A plus B. Notice how it also forms a smaller square of side length C which has an area of C squared. We'll put this to the side and call this figure 1. Now let's rearrange the 4 triangles in this new figure like this. Do you see something interesting? This arrangement forms 2 squares, one with an area of A squared and one with an area of B squared. Since both of these figures have the same area, it means that this blue area in figure 1 is equal to these blue areas in figure 2. Therefore, A squared plus B squared equals 2C squared. This is the Pythagorean Theorem, one of the most famous theorems in mathematics. Some people also call it the Pythagoras Theorem, which is named after the person who discovered it. It states that when these 2 lengths of a right-angled triangle are squared, then added together, it will equal the square of this longer side. We can express this relationship using the equation A squared plus B squared equals 2C squared. Likewise, by rearranging this equation, we can find that C squared minus A squared equals 2B squared. Similarly, C squared minus B squared equals 2A squared. The side lengths A and B are called the legs of this triangle, while this longer side C is called the hypotenuse. Here are some simple examples of the Pythagorean theorem in action. Say we have a right-angled triangle with leg lengths of 3 and 4 centimeters. We can use the Pythagorean theorem to find this missing side. All we have to do is use the formula we just learned. Firstly, we square the 2 side lengths A and B. Then we add these 2 values together. 3 squared is 9, while 4 squared is 16. Adding these 2 values equals to 25, which is also equal to the square of the missing side length. Thus, all we have to do is calculate the square root of 25, which is just 5. Therefore, by using the Pythagorean theorem, we can find that the length of this side is 5 centimeters. Here's another problem. The hypotenuse of this triangle is 13 feet long. One of its side lengths is 5 feet long. What is the length of the remaining side? I'll give you a moment to think about this question. The solution is pretty simple. We just need to reverse the formula. We square the value of 13, which is 169. We then minus the square of 5, which is 25 from it. This comes out to 144. Again, all we need to do is calculate the square root of 144, which is just 12. Therefore, the length of the missing side is just 12 feet. However, it's not always that simple. Often, when solving these problems, we end up with side lengths that are hard to deal with and can't be simplified further. In fact, there are very few right-angled triangles with all 3 of their side lengths being whole numbers. When all the sides of a right-angled triangle are whole numbers, the set of numbers is called a Pythagorean triple. For example, we've already seen some Pythagorean triples in earlier problems, namely 3, 4, and 5, as well as 5, 12, and 13. Here are some more examples of Pythagorean triples. These Pythagorean triples satisfy the equation A squared plus B squared equals C squared. This means that if the 3 lengths of a triangle are all part of a Pythagorean triple, you can be sure that it is a right-angled triangle. For example, a triangle with side lengths of 7, 24, and 25 is definitely a right-angled triangle, due to the fact that the set of numbers 7, 24, and 25 is a Pythagorean triple. Before you go, let's test your understanding of the Pythagorean theorem. If a right-angled triangle has a hypotenuse of 14 centimeters and the 2 legs of the triangle are equal in length, what is the length of this side? Here's a second question. If the set of numbers 3, 4, and 5 is a Pythagorean triple, is the set of numbers 6, 8, and 10 also a Pythagorean triple? Comment your answers down below. As always, thank you for watching, and I hope to see you in another one of my videos.